Hello, everybody. My hearty welcome to Standard 7 Physics class. In this video lecture, we discuss about Chapter 6, which deals with sound. In this chapter, we study about sources of sound, propagation of sound, characteristics of sound waves, reflection and absorption of sound, speed of sound in different media. Let us begin the topic by discussing about the sources of sound. So first of all, we discuss about sources of sound. Every day we hear sounds around us produced by humans, birds, musical instruments, machine, vehicles, etc. etc. Sound. We know that sound is a form of energy which produces the sensation of hearing in our ears. Remember it. Sound is a form of energy which produces the sensation of hearing in our ears. Sound is produced by vibrating object. Remember it. It is also very important point. Vibration is the main cause for the production of sound. If you tightly stretch a rubber band and pluck it, it vibrates. These vibrations produce sound. So what is a vibration? If vibration produces sound, then what is a vibration? A vibration is nothing but it is a vibration is a to and fro movement of a body about its fixed position, about its mean position. So what is vibration? A vibration is a to and fro movement of a body about its mean position, about its fixed position. Other than plucking, as in case of a stretched rubber band, we can also produce sound by striking, as in case of tuning fork, by blowing, in case of a whistle, shaking in case of bird, flapping its wings. So there are various sources of sound which are present around us. Some of the sources of sound are musical instruments, vocal cords in our bodies and machines. First of all, we discuss about musical instruments. Musical instruments are the instruments which are created to produce pleasant musical sound for our merrymaking, for our enjoyment, for our relaxation. The different types of musical instruments are string instrument, wind instrument, percussion instrument. First of all, we discuss about string instrument. In string instrument, sound is produced by vibrating string. When the string are plucked or struck, they vibrate they vibrate to produce a musical sound. Some examples of string instrument are veena, sitar, and violin. In this string instrument, we hit the string, or we pluck the string to vibrate it, and the vibration of the string produces the musical sound. Wind instrument. Wind instrument produce sound when air is blown into them. When air is blown into the wind instrument, the vibration of the air column produces sound. Some examples of wind instruments are flute, whistle, saxophone, etc. Wind instrument vibrating air column produces sound. The vibration of air column, the vibration of air inside the wind instrument produces sound. Now percussion instrument. This instrument produce musical sound when the skin or the membrane on them are struck. When we strike on the membrane of the percussion instrument, it vibrates, and the vibration of the membrane of percussion instrument produces sound. For example, examples of percussion instruments are tabla, dholak, and drum, etc. The next one, which produces sound, is the vocal cord. Vocal cords are also known as vocal folds and are located in our windpipe. This is the position which shows the vocal cord of human being. We produce sound by passing air through it. When air passes through it, the passing of air produces vibrations of the cords, as a result of which sound is produced. So how do we feel the vibration in your throat? First, you place your fingertips on your throat, hum for a minute or two, talk to your friend with your hand still on your throat. You conclude that you feel vibration on your throat whenever you make a sound. It is because of the vibrations of the vocal cord. The vibration of the vocal cord produces sound. Now we discuss about propagation of sound. Sounds moves through a medium from point of generation to the listener, from the source of sound to the listener. When an object vibrates, it sets the particle of the medium around it in vibration. Particles of the medium in contact with the vibrating object are first displaced from their equilibrium positions. Then they exert a force on the adjacent particles, as a result of which the adjacent particles get displaced from their mean position. After displacing the adjacent particles, the set of first particles come back to their original position. This process continues in the medium till the sound reaches to our ear. Thus, the particles of medium do not move forward themselves, but the disturbance is carried forward. Thus, propagation of sound can be considered as the propagation of disturbance in the medium. Hence, sound can be visualized as a wave. In this manner, sound can be visualized as a wave. When a vibrating object moves forward, it pushes and compresses the air molecules in front of it, creating a region of higher pressure. The region where the particles are crowded together is called compression. When the vibrating object moves backwards, the particles move apart, and it creates a region of low pressure called rarefaction. As the object moves back and forth rapidly, a series of compression and rarefaction is created in the air. This makes the sound propagates as a wave through the medium. Thus, the sound is propagated as it sets the particles of the medium to vibrate. In the absence of a medium, there would be no particles around the object to carry forward the vibration of the object. Thus, sound cannot be propagated without a medium. Sound always required a material medium to propagate. For the propagation of sound, it requires a material medium. Sound wave as a longitudinal wave. Sound propagates in the medium as a series of compression and rarefaction. In these waves, the individual particles of the medium move in a direction parallel to the direction of propagation of disturbance. The particles do not move from one place to another, but they simply oscillate back and forth about their mean position. The waves in which particles of the medium move in a direction parallel to the direction of propagation of wave are called longitudinal waves. Remember it. This is the definition of longitudinal wave. The waves in which particles of the medium move in a direction parallel to the direction of propagation of wave are called longitudinal waves. Hence, we conclude that the sound waves are longitudinal waves. So in the next video lecture we discuss about the characteristics of sound and reflection of sound, that is about the echo formation. So this is the first part of the video. In the next part we'll discuss the rest things. So thank you very much for watching my video.